Although I don't know how much space is so.
Yeah, that sounds.
That's what I was.
Thank God, I wasn't expecting it.
Sounds.
I did it. I just want that. I just haven't seen the picture.
Wow.
What's this? Is this for all of them?
I figured that sure came from the zoo.
What? Yeah, man.
This is that's
Yeah, feel free to eat me somebody who's not here already.
What's the name of his work? I like to just be comfortable.
I think I wasn't even have a. Nope.
How are you?
Yeah.
That was like.
Yeah.
And like, oh, sure.
Yeah. And if it wasn't that, it was, you'd have to justify it. I can try. I mean, that would be great. Right.
Did I not take pictures?
Oh, yeah. So.
Yeah, you just stick to this.
I know, but it's not. I just thought that too.
You're on soldier mode. Like this.
No, I'm on scene intelligence.
Why would you even say that? He's right.
Really? All right, so real quick, so you guys are kind of on board with overall the topic tonight. We're going to talk about a walkthrough for deploying an internal PowerShell repository through VSTS. This came out of an effort that we did here when we were trying to deploy our first set of official internal PowerShell packages for the teams. We decided that we'd rather do an actual repository rather than kind of finagle something together. So we figured it out on the fly, and then afterwards wrote a breakdown for the walkthrough so that other people could follow through on it, since we think it's a pattern that other people will try. So a couple of caveats. First, the private gallery is currently a preview-only piece, so there's some stuff that's missing. Right now, one of the things that's missing is being able to upload scripts like you can to the public gallery. But for the most part, as long as you're doing packages and packages only, you're good to go. So the first thing I'm going to do before we go and start doing the actual kickoff is I'm going to come in here and queue a build, because they take upwards of 20 minutes. So while I'm walking you through how to get going on this, we will do that piece. So. Come down here to deploy gallery, queue a build. So you'll see down here that there's a bunch of build time variables that we've got here. We'll explain these as we go. For right now, I'm just going to kick it off so it'll run in the background. All right. Okay, so first things first, if you're interested in doing this at home later, for people who are watching online, you can follow along if you feel like it. I put together a repository that contains all the code and pieces that you're going to need, so you should be able to just follow along between the blog or this video and the repository here. Fork the repository in GitHub and you'll be good to start. So I already have my own fork, obviously. Next thing you're going to do, if you don't already have a VSTS account, is you're going to need one of those. You can connect any of your Microsoft accounts up to it. So in this case, I'm going to come down here and I'm going to start a new project. Leave the version control as Git and the process is Agile because you're not going to use any of that, at least not for this piece. So that'll take a minute while it goes ahead and builds. Has anybody used VSTS before, or TFS itself? Okay, so VSTS is just the cloud version, the one that runs in Azure, the hosted version that Microsoft offers. What seems to be true is that processes and features that come down level to TFS come to VSTS first, and then as they figure them out, they'll backwards port them. So then you'll navigate to your project once it's stood up, ignore absolutely everything except for build. So you'll come to build, and this is where we're going to spend most of our time today when we're talking through how to put together a build. One of the things that you're going to need to do is add your endpoint. You're going to need to add GitHub as your endpoint here. So I come over here. There's a piece up at the top under your settings called service hooks. This is where we're going to add a VSTS agent, and we're going to add our GitHub piece. This is mostly straightforward. Stop me if I end up going too quick though. If I can find GitHub, and I can't because this isn't where it lives, because it's actually under the build itself. So if I come back to the build, I don't care about your birthday, Paul. Well, that's not true if you're watching, Paul. I don't think you are, but so we'll do a new build definition first. Come down, you want to specify an empty build definition, which just means I don't care if you have any pre-started tasks. I'm going to do it all myself. And then here you'll specify that you want to use GitHub for one of your repositories. Go ahead and hit create. When I come over to repository, it's going to talk to me. It's going to say, hey, you don't have anything specified here. I don't have anything that I'm aware of, so go to manage. And then under services, you can come down to service endpoint, GitHub. I'm going to grant authorization. It's going to do a little pop-up. It's just going to use OAuth to authenticate me with my GitHub account. So as this slowly grinds through, or doesn't. Let's try this one more time, VSTS. Don't ruin this. Hey, all right. So I figured it out. If you've never authenticated before, what it'll do is it'll pop up with your GitHub account, and it'll ask you if you want to allow VSTS to have access to your repositories, etc., which in this case I do. I'll carry on. Go back to my actual build. Right, so then it loads up, and I'm going to come down and I'm going to select my fork, which is the PSPrivateGallery walkthrough. That's all I need to do at this stage, so we're going to go ahead and save before we add any other steps, and we'll just call this, if I could type, deploy the PS gallery. All right. So then back over here, if we come back to the service endpoints, we're going to add another one for VSTS. This time we're going to connect it up to the Azure Resource Manager because that's how we're going to deploy today. I I need to pull up this data in a way that is not going to give away all my information. I guess I could just delete it afterwards. Did I save it to the C drive? Maybe I did. Alright. What we'll do instead is we'll go ahead and do it the other way, I guess. And we'll actually generate it, run a script. So there's a script in the file, in the repository rather, that is here under scripts, and it's just to add a Azure Service Principal account. So you need a Service Principal account to connect over. It's an account that you've delegated authority to that is allowed to run builds and execute things in Azure for you. So we open it up and take a look at it real quick. Has a couple of parameters: the subscription name, the password that you're going to give for the application, and then the role. By default, it's going to go to owner. So go into scripts. All right. Actually, I think mine is. That's my subscription. My subscription name might be Visual Studio. We might error out here because I'm not sure offhand if it is actually Visual Studio Enterprise or not. Password. Super secure. Good. That'll fail out for sure then. Thank you, by the way. Wouldn't be a demo if I didn't screw it up. Yep, that's an E. There's an R. Oh, really? Not going to capture any of that? Hey, what do you know? I was right. So it's going to come out with a whole bunch of information. So this is a necessary step, especially if you haven't already set up a Service Principal account. If you already have, you can just grab the info. For the purposes of this demo, we'll go forward. So you'll see here it creates a name based on who ran it. And in this case, it also appends a GUID. So it'll be VSTS.whoevermadeyou dot a GUID here. That way they're always unique, so you could have multiple Service Principal accounts. You're not going to have collisions. Let's check on that first build real quick. There it is. So like I said, it's still running. It's deploying the resource template that we're going to get to here in a minute. Any questions so far? Good. Sleeping? Potentially? There we go. All right, and at the end it gives you this little string, so most of you won't be doing this during a presentation, so you won't have to worry about it. The only thing here that you really need to make sure you protect, though, is your tenant ID, which I've helpfully highlighted so you can steal it. All this information is going to be required whenever you go to set your VSTS endpoint here. So we come back over here. Wants to know my connection name. So in this case, you can literally just highlight and go. If you can highlight effectively. password we set earlier for the key, and then my tenant ID. All right, and then that's set up. So then when we come back to the build piece itself, we don't need the endpoint anymore. And I shouldn't need PowerShell for a little while. Okay. So we're still building. Here. So we have, I can avoid clicking on things. So we've gone through steps 1 and 2 pretty quickly. The next part is the actual build, which I'm going to actually bring up the reference for because it's not like I can remember all 12 steps offhand. So the build definition is the part that's going to take the longest. It's the part that is going to be the most complicated because we're going to do all the pieces that are already in the repository, set it up. We're going to tell Azure what parameters to use when it's deploying the template, and then what pieces we want to overwrite in the DSC config for our specific deployment. So we will go through that now. There's a couple of variables that we're going to set first in VSTS down here. So of all of these, the ones that we're going to set tonight, there's a couple that I wouldn't normally set if I was doing true infrastructure as code. When you're doing true infrastructure as code, you want to keep the names and stuff in your actual source code. You don't want to overwrite those at build time necessarily, because you lose kind of the context of why you're making the changes to the server names, etc. But you do want to keep for sure all of your secrets in the VSTS build. So the secrets are kept, they're encrypted at rest, they're decrypted at runtime when you're doing the build, and they'll be injected into the stuff when you run it, so you're not actually storing in your source code the API keys or the admin passwords or any of that stuff, which would be a pretty terrible idea long term. So we're going to come down, we're going to go to add a build step. The first build step that we're going to add is under deploy, and it is deploying the Azure Resource Group. All right, so you see that there's a whole bunch of pieces over here. You're going to click on the Azure RM subscription, and it should pop up with the service principal you set up earlier. You give the resource group a name. So in this case, we'll just call it STLPsug Gallery. We'll do dash gallery with a G and not an H. Is everybody familiar with resource management templates? Has anybody seen them before? Nobody? Okay, so templates are just JSON documents that are used by Azure's resource management type, which is what replaced the classic portal. So we're going to take a look at one of those real quick as well. So it's literally just a big JSON document, JavaScript object notation document, which specifies everything you could possibly want to specify about the stuff that you're going to deploy to Azure. So it breaks it all down. So if we look here, there's a couple parameters at the top. So the admin's username, the admin's password, and you'll notice that here in the source doc, we have it set to admin password. That's because we're going to overwrite it at build time with the stuff from the VSTS build variables. So the image offer, the image SKU, in this case you'll see that it's deploying under 2016 technical preview. The reason for that is we tried deploying to a 2012 R2 and it does not work. There is a unspecified requirement that it needs PowerShell 5.1, not just PowerShell 5, which is in the fast ring for Windows 10, and it's on 2016 Preview 5. You can set the VM size, the name, everything, all those kinds of things down here. There's a couple of variables which we don't set at run that we've left here. So the next part, the important part of a template, is the resources. So this is the stuff that's actually specified when you're doing a deployment. So here, the first thing that it specifies is storage, and it gives the parameters for storage. Now, I didn't write all this by hand because there's no way I would have known any of this without crawling through the API forever and ever. They have a repository called the Azure Quick Start Templates, which we pulled a lot of this from and used it to bootstrap what we're doing. So I'll send out a link to that as well at the end. But you'll set up your storage, you'll set up your public IP address, you'll set up your virtual network, the subnet. You'll have to set up the actual instance itself, the network interfaces, and then the big part is the VM. So the VM's got some subcomponents of it, the OS profile. Down here we tell it that we want to have an HTTP listener. That's for this, that's not for best practice. We prefer HTTPS since we've got stuff external to our domain and we can't necessarily trust it all the time. Storage profile, network profile, and then down here, these things just link it up to the storage and network resources that we created above. So then down here, under network security groups, this is pretty critical anytime you're going to deploy a VM to Azure via resource management templates. And the reason for that is if you don't specify these, by default the firewall will block all traffic to your VM. So make sure you at least open up the firewall for PowerShell. In this case, we're also opening up inbound over port 80 because that's what the PowerShell gallery is going to sit on. So if you have any questions about the template, let me know and we can go into more depth after the deployment. Check back on this guy. Still deploying.
Can you make that go over SSL rather than just port 80?
Yeah, so that's what we tried first. The problem that we ran into is that the package management on the client side right now has a bug in it where it fails to load SSL package repositories. So we did test that you could hit the website over SSL. We gave it an SSL cert. Everything was fine on the server end, but the package management module could not register the repository. We're expecting that to be fixed. We filed a issue on the GitHub page for the PSPrivateGallery. So back over here, kind of talked about that. We've got some template parameters here that we're going to go through and overwrite. So back in the templates, there's a parameters document which you can use to set the parameters before runtime. In our case, we're going to overwrite pretty much all of these except for the VM size. And we're just going to deploy to a standard A2, just a small-ish VM. And you'll see here that most of them share their normal name is computer name. That's because when we run our provisioning script here, what it's going to do is it's going to replace computer name with the name that you specify for the VM and the build variables. Normally you would name these whatever it is you actually wanted the resource group to have. You wouldn't do it at build time. But for convenience sake, that's how we're doing it. So back over here, we're going to do resource group name, VM name. So over here is where you define the variables. So in this case, the resource group name. VM name. I never thought I would regret having front printed keycaps, but right now I do. VM admin account and VM admin password. Spelling is important. So these are case sensitive, by the way, as far as I can tell. And we're using, for this case, because this is what VSTS uses by default. It's what JSON and JavaScript tends to expect. So, and then the gallery admin and gallery user passwords. And then the gallery API key, email address, and name. Alright, then we're going to fill in the stuff for this. So I think we said that it was going to be called the STL psug-gallery. And we'll call the VM STL psug-01. VM admin account we're going to call my admin, the VM admin password. So I'm gonna do it in plain text so you can see it first. We'll do, like, click in the right spot. So before you do that, you're going to want to click the secret button over here, which will immediately hide it. So for right now, whenever you're first putting a secret in, you can hide and unhide it at will. But once we save this, we won't be able to retrieve it back, right? It'll be encrypted at rest and it'll only be retrievable at build time. So when you want to overwrite it, you will have to come in here and just rewrite the password that you want. But you won't be able to retrieve, in this case, Apple1234 back out from the build process, even if it's the person who put it in, right? I can't retrieve it from here. So then the gallery admin password, we're going to do the same thing. We're just going to use Apple1234 for everything. Well, that's not Apple. We'll do that for the user password. And then we're going to generate a GUID for the API key. So this is what you will use whenever you're publishing a module upstream to this gallery. And in this case, we're only building one user. You can modify the DSC script to have as many users as you please. So in this case, we're going to do new GUID, select, expand, GUID. So that's actually a select object with a B. Alright, so then we'll just pipe that over to, is it set clip? Set clipboard? Will that copy it? Because I know clip will do it, but clip also appends extra stuff. Do you know, Mike? We'll use clip offhand. Detour for a second. Alright, so with PowerShell 5, by the way, you can control your clipboard from there. So we'll do set clipboard. And then we'll come in here, we'll paste it in. So you may want to keep these secret. We're going to leave it plain text because we don't care that much for this instance. And that way people can try uploading and pulling stuff from the repository at the conclusion of the demo. So then the email address will be stl.psug@outlook.com, and the gallery name will do stlpsug demo. All right. So now we've saved those variables. We're going to come back over here, and I'm actually going to replace this with the resource. I remember how that happened, so that'll be piece of dash. Okay, so the next part down here is quite a bit more complicated, so we're going to come back to the walkthrough to grab it. So when we come down here, where are you? Okay, so here's the complicated part, right? So this piece right here is what we need to pass in the parameters to overwrite what's in the parameters files with what we want. So in this case, we're saying that the new storage account's name should be VM name, that the DNS name for public IP should be the name of the VM, and then the admin username will be the username we set. The password will be, it'll convert that, the password stored in VSTS to a secure string. You need to do that because when it decrypts it into a regular string, not into a secure string. So you'll need to convert it before you pass it along to your build. And then the VM name will be the name of the VM. So let's take this piece right here. Copy. I don't want to ask Cortana. Come into here, overwrite those template parameters. Okay. Nope, that actually is in the wrong spot. That'll go here. The parameters document is what you'll set here, I'm sorry. So that'll be under templates, Azure deploy.parameters.json. And we're going to enable the deployment prerequisites, which all this does is it sets up PowerShell HTTPS on the node for the rest of this. so that you'll be able to connect to it and run your commands for the file pushes and stuff. And then down here, we're going to set it to nothing. So we'll save this first piece here. VSTS allows you to do comments. It's kind of, sort of like a terrible source control for your build process. Anytime you make a change, it'll be associated and you'll be able to look back. So I guess we'll do initial build and save it. And then when you come over to the history, you'll be able to see it. So we added it in the first place, and then we made a comment for the initial build. So if we come back to the variables, just to show you that you can't retrieve that password, if I unhide it, it goes away instead of revealing it to me. So if somebody did get access to your VSTS and didn't already know the password, they could not retrieve it from here. You can overcome the problem of not knowing what your passwords are by using a Azure Key Vault, but that was a little bit complicated for the scope of this, so we left that part out. So we'll save it again. Removed password. So the other cool thing is we can go back in time to any of these builds, and we can check the diff between the builds. So we can see what they kind of look like between each other. So if we do diff here, it shouldn't show anything different, right? Really? Okay, so it just placed it over. Clean was redefined to false, etc. Okay. So then we come back to the build over here. We'll check on you. Hey, it finished. So now when we go into Azure, if I go to the portal, under resource groups, so the build that we just put together, if we had to run just that piece, this is what we would see. So let me, I don't care about the settings. I'll full screen this. Okay, so you'll see that it did build the VM, it put together the NIC, it gave it the security rules, the public IP and the virtual network and the storage account. So if we click on the security rules as an example, and then we click here, I want to see the inbound security rules because that's all we set. So we have two inbound security rules, one for allowing WinRM and one for allowing HTTP. Those are the only ones we set. Those were specified in that template. If you change the template and redeploy, it'll change these rules if you remove them, or it'll add new rules if you put new ones in there, or if we decided to allow HTTP inbound and HTTPS inbound, we could do that. But you can make those changes straight from the templates instead of having to edit here in Azure and have it, be, well, Bob logged in and he changed this and I don't remember why, but there was a problem. Now when you make those changes, you can make the changes to the template in source control, include the commit message and all the history of why you made that decision. So it's tribal knowledge that's available and searchable to the rest of the team. So for now, that's all we're going to do here in Azure, except I want to show you that the VM itself did deploy and that it has a name, surprisingly enough. So the name down here is pspg01.eastus.cloudapp.azure.com, which is what we're going to use to register the PS repository at the end here. So if we come back here to the finished build, we're going to come down to edit, and this time we are going to disable these three pieces because the files are copied over now, and we'll enable just these two. So the reason we do this is that the output of the deployment here is a variable called resource group, which I may have left off on the other part. This variable gets passed along, which means you don't have to specify any of the additional stuff for your machines. It'll apply to all machines in that resource group. So if you deployed two different VMs for the private gallery and you wanted to do failover across them, or if you wanted to put them both behind a load balancer, you could do that, and then it would just use this and apply to both. So it allows you to kind of skip a couple of steps there, and we'll come back and talk more about those variables here in a minute. So I guess I should queue that build, huh? So we'll save it. I'm not going to comment on my own one. So I purposely avoided testing too much because you only have 240 free minutes of VSTS build server time, which we know intimately here because we ran into that limit and had to get extra. So I'm hoping I didn't accidentally use too many minutes figuring all this out, and then it'll fail out on us when we try to run it. So we come back over to here. We've got that first step built. We're actually going to come up here. This will be group name, and then under variables. Yep, okay. So that'll be fine. And then we're going to do a new build step for the deploy. And the next part, unfortunately, we need 3 pieces for. We're going to do an Azure file copy. So, unfortunately, you have to specify. Oh, I may have just added a whole bunch. Yep. Okay. Well, we need 3, so that's fine. So, for Azure file copy, you have to specify 1 file or folder. So, if you're going to move a whole bunch of files, put them in the same folder and just move that folder. It will not take multiple folders or multiple files. It'll fail out on you and give you errors. So we come back over here because I checked that. Okay, so the first thing we're going to do is copy over modules, and then installers, and then the configuration. Okay. So back off to the side. Not to your own. Fine. So we're going to come specify that we want to use the modules folder here. And we're not using the classic subscription, we're using the resource manager. This one, the destination type is going to be the VM. So because it's already, well, in this case it hasn't already deployed, so what we're going to do is we will do $VM name and the resource group will be resource group name. The admin login was VM admin account. So stuff like this you wouldn't necessarily want to put. Really? I haven't been doing it for that long. Okay. It's gonna be interesting because I don't think there's an extension cord. You got it, Danny? Thank you. So, well, the stream may die very shortly. We're about to find out. Thank you. Appreciate it, Mike. So the reason that we're doing this is basically you're just calling the substring from the variables. It'll read this piece here, anything between the $sign and the parentheses, it'll read as a build variable, and it'll inject it before it puts it into PowerShell and runs the rest of it. So behind the scenes, all it's doing is running PowerShell. Grab my charger real quick before this whole thing dies. Appreciate it, Brad. Do we have... No, apparently not. No. Well, I guess I can shovel this closer this way. All right, we are as precarious as we could possibly be for the rest of this. All right, fine, close enough. So, I will shift. This is a quality presentation. Sorry about this, folks. And we're gonna have to go at the edge here. Is that how this is gonna be? Fine. All right. I have no idea if I'm still in focus at all. Ah, I exist. Close enough. Right. And we're charging. Where were we? Alright, source modules, blah, 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 blah. VM admin accounts. The destination folder is going to be C installers, if I remember correctly. So for the modules. Okay, so the reason that we're copying the modules over, these are prereqs that'll need to be there for when the DSC scripts run, so it's going to look for DSC resources. If you don't copy those over, they're not there by default in 2012 R2. It's not going to be able to find them and run them. Or in this case, I guess 2016, because these are custom resources. So specify that there. And then there are no additional arguments. Enable copy parameters. Don't care about the output. We'll come down here. So after the modules are copied over, the next things you're going to need to copy over are going to be the installers. So there's a couple installers. By default right now, the private gallery has to use SQL Server Express, which is kind of a pain. But there is a issue that we filed again on the, on the repository to be able to use any SQL backend. It shouldn't matter, theoretically. So Azure VMs, this part here is all going to be the same. Again, no extra arguments there. So the third piece we're going to move over is going to be the configuration. This actually holds the DSC scripts that the private gallery uses. We're just going to execute a single piece that calls both of them, and we'll talk about that here in a little bit. Does anybody have any questions so far while I'm filling all this stuff out slowly and painfully? Oh, good lord. You're right, thank you. So VM name is fine. That'll be... Yep. Thank you. On the destination folder again, we're going to do enable copy prerequisites, and that'll be that. Okay, so we'll go ahead and save again, and we'll add the comment for added file copies. Let's swing back around and take a look at... Did it what, it closed? That's not good. Alright, so we will open up the new tab, go check on that build, I guess. It closed on me. So we'll come back down here to the PSPrivateGallery I did. So everybody still with me so far? Anything been confusing or problematic? Going too fast, going too slow? So, under the deploy, queued. So it's still going. Open. And it'll come back and it'll show us that output again. So it's still running. That's the important thing. All right. So what's going to happen is, in order, it's going to deploy the VM, and then it'll copy over the files, it'll copy over the modules to the module path that the remote computer is going to expect. It'll copy over the installer files we need, and then it'll copy over the configuration files, and the final piece that you need is to run PowerShell on that remote machine, which again is under the deploy folder. PowerShell on a target machine, pretty straightforward. Close, down here. So in this case, coming back up to this very first one where we specify some output here. So again, when you have the output here in the resource group, it just loads that into memory as a variable for the rest of the build. So if we had a whole bunch of stuff that was still going to happen, some after action configurations that were all going to happen on the resource group, you would specify that resource group further on down, and then it doesn't have to, you don't have to keep all the rest of that kind of thing in your build variables. It'll just know what you're trying to target. Makes things a little bit easier for you. Okay, so then down here, come back over, so you get the resource group. You need the login, which, as you're probably familiar with by now, is the VN admin account. Admin password. We're going to go over HTTPS, and then it'll pop up and it'll tell you that, you know, are you using the test certificate, which in this case, yes, we are. And then we're going to run PSPG configuration execute. I think it's configuration scripts. Let me double check on that. Yep, execute configuration scripts. PS1. And then you can pass over the script arguments, which, again, when we look down here, you're going to see that for script arguments, we're going to use this stuff right here. So the first part is, so we're going to use the admin gallery password. So this is the account that it'll use to connect to SQL and set up all those pieces. Everything behind the scenes that the service account will need, that's basically what the gallery admin is. And then there's going to be the user password. In this case, we're only setting it up for one user again. So one user, one API key, one email address. So if we select everything except for that, come back over here, copy, drop that in here. Okay. All right, and that is all there is to that piece as well. So, okay, so that's actually setting up the build, and then you saw running the two parts of it. So the reason we do that is that the free tier has a 30-minute maximum for your builds, and unfortunately, as you saw, the actual deployment to the resource group takes upwards of 20 minutes. The DSC resource can take 15 to 20 minutes. So what will happen is you'll get an error that says it failed. And it'll say that because it'll just cancel out at 30 minutes, but the DSC configuration won't stop running once it's been kicked off, right? And in my experiments, it gets to that point. So technically, you can do it in one shot and it should deploy and work exactly the way that you're expecting it to, but you will see a failure mode and it won't give you back the results. So, come back over here. Never find. Not going to give us the output, I guess. That sucks. Okay. Anyway, so it's applying that DSC config, which we're going to go ahead and poke our heads at now. So if we come back up to the private gallery walkthrough, and we drop into configuration, and then the execute configuration script. How many people in the room are familiar with DSC at all, Desired State Config? Okay, so what we're basically doing is we're going to overwrite some of the environmental data files ahead of time because we're deploying it kind of as a walkthrough and not the way that you would normally. So normally you wouldn't do any of that. You would just deploy it with the correct data files intact from your source control, right? Presumably you're also not going to share it with the entire world when you're deploying your own internal infrastructure. I guess you could, but usually you won't. So up here, the script is going to take a couple of parameters, the admin password and the user password. There's an enhancement probability here. We could take those as secure strings instead of regular strings. So the whole thing's in a GitHub repository. I'm going to make continual updates and improvements over time. So if you're interested or you see something you don't like or whatever, let me know, and I'll retarget and try to fix stuff. Then you're going to take the API key, email address, and private gallery name. And then what it's going to do down here is it's going to set the location to the folder in which the script lives. It's going to make 2 credential objects and output them as XML. Those are going to be read in by the DSC script later. So they're sort of encrypted. Only the user that makes them will be able to get them back, which will be the local admin that you create for the box. So it'll read those in and it'll use those when it's running DSC, because some of this stuff has to run under a user context. Specifically, being able to add the repositories runs under the local user context. So, then it's going to update those environmental variables inside. So the first thing that happens here looks a little bit complicated, really isn't. What happens is everywhere inside the data files, where you would normally have what we would specify for our own private gallery name, we just wrote PSPrivateGallery. So it'll overwrite anywhere in the data files that defines PSPrivateGallery with whatever you specified. In our case, STLP_SUG_demo, right? And then it'll do the same thing for the second file. Again, it'll overwrite PSPrivateGallery, and then it'll overwrite the default email address and API key that are in there with the ones that you specified during the build. Then it will go ahead and execute the 2 scripts, which I think are mostly or almost entirely untouched from what Microsoft released with the private gallery itself. So we'll go take a look at first the environmental data files. So these are pretty simple. They're essentially just big arrays of hash tables that gives you information. So you can have 1 node or 12 nodes, however many you want here. We're only specifying 1 because that's all we're standing up. So it says that it's going to run on the local host because we're running these locally. We're not running these through Azure Automation or anything. The role is going to be web server. It's going to allow the plain text password. And then the URL rewrite path, SQL Express path. This is the stuff that it needs to set up the gallery. So most of this we leave untouched. The only thing we really change in here at all is that we change PSPrivateGallery down here, so the SQL instance and database names will instead match up with whatever the private gallery is. Again, this is an example. This isn't how you would necessarily do it in production. The other thing to notice is that we're gonna install it as the default website on this box, just for ease of configuration and use here. So the next part then, once it has those data files, go ahead.
So is that you can install a SQL server?
Yeah. Yeah,
Yeah,
just tell it what you want it to be, and it'll do it. So as a separate side conversation, the SQL Express has got a okay configuration stuff set up for it. The thing to be aware of is that this doesn't include all of your best practice security stuff that you're going to want to do for SQL, right? So it's literally the same as being like, I want you to give me a SQL instance, and then do the bare minimum to set that up for the gallery and leave it, right? So if you were going to be hosting any sort of restricted data inside it, you would want to go back and harden it anyway, right? So again, things that enterprises in the real world are going to want to do that aren't in the scope of a walkthrough for how to do it, right? So then we're going to come down and we're going to look at the actual piece that deploys it. So if you're not familiar with DSC, it's probably going to look a little bit scary to you, but this first part up here is a configuration for the engine that DSC uses to get all of its work done, the local configuration manager. And all it's really saying is that for the local host node, I want you to make sure that if it needs a reboot, it'll do the reboot. You'll configure the node only once. There are 3 options in DSC. You've got apply only, apply and monitor, and apply and autocorrect. So those are in increasing order of how strict you are with your configuration. So apply only, it'll apply it, it'll run the configuration we're giving it, and then never think about it again. If you do apply and monitor, it'll apply the configuration, and then when it drifts, it'll trigger a event. It'll tell you, hey, I checked in at this time and I found that your SQL server had been uninstalled, or that the instance that you had set up has been removed or changed or whatever. And then apply and autocorrect it will run the tests to see what your DSC configuration is, and it'll be like, hey, this isn't what I said you're supposed to be, and it'll turn it back to the way that it thinks it's supposed to be, right? So using apply and autocorrect means that if you're going to be making changes that violate the baseline, you have to make them in the configurations. Otherwise, they're just going to bounce back on you, which is pretty interesting long term, but I think most shops aren't going to be there for a while. So the next part is the actual configuration of the installer for the private gallery. So in this case, we're going to import some DSC resources, the custom resources that we had to move to the server, PS Gallery and X Web Administration. So this is how you configure IIS, and this is the custom DSC resource that they released for the private gallery. This is under heavy construction still. So then what it'll do is it'll look through, come back up here, new tab. So it'll look through this file for all of the nodes whose role is web server. So this is one node, and the only node we have is, shockingly enough, the web server. I'm apparently clicking too quickly. So what it'll do is it'll say, I want all the nodes that are a web server, and then I want to do the same config for all of those. So it'll grab the credential, and here it's going to grab the admin credential file. So it's going to use that for the duration of this. So down here it says for the gallery web server, I want you to pull the data that we had in the environment file. So most of the data that you have lives in that environment file instead of in the config itself, which means when you want to deploy 5 or 6 or 12 of these VMs, you don't need to write extra configs over and over and over again. You can just change the data files that you feed to the configuration. So in this case, it's going to pull the URL rewrite package path, which you'll see here. It's going to pull the SQL path, same thing. Gallery source, the website name, website path, website port, and app pool name. All that data is what we saw in here, right? So it's going to pull all that, and that's what it's going to use to configure the gallery web server. And then for the gallery database, it's going to look for the SQL Express package path to install it, and then it's going to specify the SQL instance name and the database name to give it. And then down here, for the database migration, I'm not really sure what this step does. There's not a lot of documentation on PS Gallery's part, so I'm not sure exactly what happens in here, but the settings are also in that data file. And here you can see that it does depend on this step being completed first. So in DSC, anytime you see this key depends on, it will not run or check unless the other part runs, right? So if you get a failure mode and it breaks out, you're not going to run through this piece either because it knows that it depended on that previous one. There's no reason to check it. So then the next part, the last piece of this one, is the web connection string for the database that you set up. And that again this is the one that I think is mostly built in here rather than in the data file. But again, it's using the instance name from the data file and the website name to build this connection and add it to IIS. And you'll see that this one depends on the web server and the database migration have both been completed successfully. So then the next thing it does is it's going to put together the LCM config first, and then it's going to set the local configuration manager to use that config, and then it'll do the same thing for PSPrivateGallery, and it'll start the DSC configuration for that piece. So this runs before the second configuration does. The PowerShell team broke it out into 2 files, and I didn't concatenate them. So once this is finished and this completes, we'll return to the execution script, which will run the next set of configurations. So if we come back to here, configurations, so the publish piece, and then I'll look at that data file first as well. Okay, so same thing, we're only configuring one node, but you'll notice that the data in here is a little bit different. Again, it's going to run on a local host. This time the role that we're specifying is gallery. And again, we're going to allow plain text passwords. We're going to grab those same credential files. We're going to use the same instance and database name. But this time we're going to pull the email address and API key. So remember, when we ran the execute scripts, it overwrites these values with the ones that we've got pulled up in, excuse me, the ones that we have pulled up in the build variables, right? It'll overwrite these with those ones. And then down here for the private gallery name, this will get overwritten, in our case, with STL psug demo, and it'll run on localhost on port 80. And then the source gallery name, we're just going to pull from the public gallery, the PS gallery, and that's its URL there. And the last and interesting piece of this is where we specify the modules. So in our case, we specified a minimum version for the modules that we wanted to load because we always want to have the latest. You can specify a minimum version, a maximum version, or a required version, which unsurprisingly, it'll be at least that high. It'll be no higher than the maximum version, or it'll be exactly the required version. So if you know that a module you're putting out has a dependency on a package, and you don't know if a newer version of that will work, you can make sure that it's only going to store the required version until you update. So when you redeploy and rerun this configuration, you can change what's on there, or you can upload the package yourself if you're going to do it manually. So the story around managing the private gallery is a separate conversation, and we should talk about it, but it's not a great story right now. So that's all in the data file. And we come back to the actual script that runs it, same thing, we're going to import some DSC resources, in this case package management providers and PS Gallery again. And then for all nodes where the role is gallery, which again there's just the one node, we're going to do the following configuration. So we grab the credential files again, and we have a configuration for the source gallery. So what this does is it registers the source gallery as a PowerShell repository. Ensure is present, so it's going to exist. If it was absent, it would remove it if it did exist. The installation policy will be trusted, so it won't have prompts whenever it's trying to install for itself. It'll use the admin credential to get this done, and it will have the source URI and provider name that we had specified in the previous, or I'm sorry, the name of the gallery itself in the data file. The provider name for PowerShell repositories is PowerShell Get. Then we're going to set up our private gallery. Again, it's going to pull the name and source and credentials all from that data file. It's going to ensure that the private gallery does exist and is trusted. Same provider name. So here it's only going to have one user. If we had specified multiple users in the data file, it would set this up once for every user. We could write the configuration a little bit differently to do that, but in this case we're just going to have the one. So in this case, it's going to load that user into the SQL instance and database that we specified. It's going to ensure that the user exists. It's going to use the credential for the gallery user that we had specified. It's going to run this command as the admin that has access to SQL. And then it's going to give it the email address and API key that were specified in the build variables and in the data file. And then finally down here, the more complicated piece is the PS Gallery module. This is what's going to ensure that the modules that we had in the data file are actually loaded into the private gallery when it's built. So ensure that they all exist, pulling from the source gallery, putting them to the private gallery, running it as the admin, uploading it with the API key that we specified for the user, and then the modules that we had specified. So this block here just adds a sub-configuration for each of those modules, specifying whether it was on name. And then the interesting piece is that they can only have a required version, a minimum version, or a maximum version. Obviously, if you have a required version, you can't also have a maximum. We've already specified the only way that you can. So it'll read any of those three values, whichever ones exist. In our case, we only use minimum, and then it'll build a module specification configuration for that piece and apply it. And this part, of course, depends on the source gallery existing, the private gallery existing, and the user existing. Otherwise, it's not going to get anywhere with this piece. And then it'll turn all of that into a MOF file, run the configuration, wait for it to finish out, and let you know how it goes. So, all things being equal, our build should be finished now. Okay, so if we come back to deploy the gallery, you can see that the build, okay. I apologize for all the shenanigans with the browser tonight, by the way. I've had the Surface for less than a week, and I'm still getting the hang of using it. Alright, so that's what the deployment looks like. Are there any questions about the configuration of the data files or any of those concepts? It is a little bit on the complex side, especially splitting it across two configurations. But these only run once in our case when we're doing the walkthrough. We're only going to run it whenever we deploy. So you have theoretically successfully deployed. If you've gotten to the end of that, you set it up and you've run both and the tasks come back with no errors like ours did. So let's go ahead and test that part. Those of you who have your computers out are going to be able to navigate to the walkthrough and run the code that's on the screen here, and it should work for you. So I don't know if anybody wants to do that, otherwise I will unregister and register my own. That's not clear. That's caps lock clear. Alright, so really gonna turn off the AC? Alright, so you'll see that I have the STL-PSUG one already loaded. So let me didn't take me to the end of the line. I'll come up here and we'll talk about the command real quick before I run it. So you register the PS repository, specify the name, which in our case we set it to STL-PSUG. The source location, so this will be the if you haven't got your own domain, you'll use the public address of your VM. So in our case, PSPG01.eastus, so the region .cloudapp.azure.com, that's all standard, and then you'll append API version 2 because that's what the gallery uses, and then the installation policy is trusted. So we'll go ahead and run that. Hopefully it won't fail out on me. Okay, and then if we do get PS repository again, I will learn to type someday. See, it's loaded, and if I do find module dash repository STL-PSUG, you'll see that it's got those modules that we'd specified. So in this case, Saki, PS Script Analyzer, Pester, PoshGit, and PS Deploy, which are the ones that I usually use when I'm doing my development. So the next part would be UCAN. So let's say we want to define the module for Saki and install the module. Scope. User. Oh, I already have it installed. Oh, shame. So if I do get module, get dash installed module, Saki, it'll show up. So then I can uninstall it. It's a little bit of a roundabout way to show you how to do this, right? Uninstall modules. Does anybody here use Linux? Just me? Good. I'm glad that well, I can't uninstall it. Blah, 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 blah. Now you want me to run as admin. Okay. Alright. Do I have? I probably have all of those. What are those words again? Oh, did it really?
Yes.
Why? So how much of that did you guys lose?
Like 2 seconds.
Okay, good. Good. All right, excellent. So we've uninstalled Saki. Now I'll exit back out of there. Come back up. Say again?
Just start over.
Okay, yeah, I'll take it from the top. So we're going to go ahead and we're going to find the module from that repository. We're going to install it under the current user scope. So we shouldn't need admin rights. So give us this long string of things it's doing. Finding the package, installing the package, etc. All right, so it found the repository that we were looking for, and then it used the provider that we had specified by default when we're using package management here. And then it grabbed it, downloaded everything, and installed it for us. So now when I do get installed module Saki. All right, you'll see that it's 460, and the repository that it's installed from is STLPsug. So that's how you get them. And then if I cd into, actually, all right, so let's go into the example module. So I've put a couple of things in here for an example module. And what you can do is you can publish these up to your repository to kind of see what that looks like. So in our case, all right, there you go. Publishing. So I don't remember my API key, and I think I did put it as a secret. I hope that's the right API key. Let's find out. So we go to edit, variables. Yeah, I didn't hide my API key. Good. And again, if you want to follow along, you can upload whatever modules you have that aren't already in there, or the versions that I don't have, and it'll go ahead and do that. It should take it because you've got the API key now, which I'm about to post on the screen. So that'll be up there for you. So let's do everything except for that key. So I'm going to show you something real quick because we can publish. I actually want to publish 0.1.0 first. All right. So when we're doing the publishing, the thing you're going to notice is that the syntax is pretty simple. You only have to specify either the PSM1, the module itself, or the PSD1, the manifest for it, or the folder in which it sits, and it'll find it, wrap up all the metadata, turn it into a package, and push it for you. So in this case, we're going to say I want to do. Actually, before I do that, did I go too far? I did. So we're going to go down a level into example modules 0.1.0. We're going to publish that to the STLPsug repository, and we're going to use the API key that I have up here to do so. So can't find the path because it does not exist. That would be because there should probably be a dot backslash somewhere. Oh, can't find that path either. ls. It's example module. Yep. Yeah, I see. Thank you. Well, like I said, we'll make it work eventually. Alright, so I should have done this verbose. I'll do it on the next one. Failed the process, invalid, or does not. Wonder why. I swear to God, if it's just GUID, I'm going to lose my mind, because if that was an error that I had previously, I don't know if I fixed it or not. Yep, okay, so I have to go and push that fix to the repository. So there's an error in the repository right now where the execute scripts is looking for, and I will show you the error because I am an honest fellow. So execute scripts, and if we come back up here, configurations, and look at the data file, I'll show you exactly where that error happened. So here in execute scripts, in the second part, you'll see that it's looking for API key GUID in the publish, and then over here what you will see instead is just GUID. So there's nothing for it to overwrite. So currently, if you would, I guess that makes it easier. If you'd like to publish a package to the repository, the API key is GUID. So congratulations, I guess, to that. So the next thing we're going to do is we're going to go ahead and we're going to publish example module 2.0, 0.2.0, semantic versioning, folks. Alright, so we'll do that. I forgot verbose. Thank you for saying it. I registered it after I hit enter. So then we will try to do 0.1.1. And you're going to see that it'll fail, but I will add verbose to the end anyway. So it does a whole bunch of checks and looks, and it fails out and it says, hey, you can't do that. You cannot publish a module to the gallery that is older than a version that is already out there. If your version is a lower version than one that is already in there, it will reject it. So let's go ahead and say we're feeling very confident, which we probably shouldn't be, given the way that this presentation has been going with my typing skills. Let's say we're ready to deploy 1.0. So we'll do that. And this time we shouldn't get an error back. It does give you the little process piece at the top. All right, so it puts the package together, looks in the repository. So you'll see here's that same check where it searched the repository for the example module. And then it comes back and it says, hey, I didn't find anything that was higher than 1.0. I'm going to go ahead and let you have it. So the next thing we're going to do really quick, the final piece of this, is we're going to come over here. So your private gallery looks exactly like the one that's out there for the public gallery. Now the cool thing is that you can brand this. You can do all your own company-specific edits, change the way that it looks, etc. But you've got, so if we go to modules, Saki, PS Script Analyzer, Pester, PoshKit. It does the same thing where you tell it says how many downloads you've had, etc. So right now it does take a while to update. By the way, we found this out too. It'll take a while for it to update and tell you, hey, I've uploaded your thing and this is how many downloads I've had of it, etc. But that's all there is to the actual deployment part. Are there any questions? Anybody want to talk about the concepts behind this, the infrastructure as code piece, any of that? Nobody? Okay, one person. What's up?
I have one question.
Yep.
Every place I've been,
Yep.
the general thought process was only a drop down for remote administration down to only a couple things.
Sure.
So in those situations, would it be worth trying to get private gallery? Considering you only have to be those are redundant, security manager, yes,
Sure. So the question for the people on the live stream is, since it seems to be true that most places we work, the ability to run PowerShell remotely, the ability to run scripts is pretty restricted. Does it make sense to have an internal repository in a case where you won't be able to pull to as many nodes, right? So if you've only got 5 or 10 nodes, right, that you can put your modules on, does it make sense to stand up an internal repository? I think it does. I think it does with the following caveat that not running your PowerShell commands from your workstation is an anti-pattern, right? So if you're doing the majority of your work, unless they're automated pieces that are running from a thing, so like a good example of this is if a user submits a ticket and the ticket says, hey, my app pool is crashing, I need you to reset the app pool. That ticket generates a PowerShell action that resets the app pool. That's great. If you get to the point that you can solve most of your tickets automatically, so maybe in that step, we don't want, maybe management decides we don't want to automatically reset those app pools, right? Because what if the automation goes wrong and starts rebooting app pools left, right, and center? Fine, you include a human piece, but as soon as the human approves the ticket, it goes ahead and pushes that. In that case, no, maybe you don't. But one of the things that we noticed in our last meeting was there were a couple people there who weren't from traditional IT roles, right? One of the guys that was there was somebody who is an accountant. And he'd said that he'd started using it for some data crunching when he wanted to put together queries and stuff across Excel sheets. Same sort of thing. PowerShell can be useful in those cases. If you're going through logs, you're going to be using it. So you can write, there are still useful smaller modules that you can write and put together. Once they get to the point where the private gallery can host scripts, I think absolutely you're still going to want it, because people are still going to run some scripts locally. And I think part of the problem there is a misunderstanding of the security model, right? You want to control who's running what and where. You don't do that by banning the running of PowerShell generally. You do that by having an intelligent conversation about the scope of what you're going to run, where you're going to run it, why you're going to run it, right? So moving forward, the way to do that is GIA, right? Just enough administration. So you set up GIA endpoints on your servers and you say, okay, help desk, you can log in and you can do these 12 things on this box with these parameter sets, these sorts of things. But you can't, say, delete AD groups, or you can't do these sorts of things. and then you say the SQL DBAs can log in and do whatever it is they need to do with SQL, but they can't start, I can't think of a good example off the top of my head, but maybe there's some processes that they're not allowed to stop. So if for some horrible reason you deployed a server to Azure that had a SQL instance and a web instance, like the private gallery, right? So if you did that, maybe the DBA can log in and do whatever they need to do with the SQL side of things, but they can't stop or start the app pool, they can't change any of that stuff. So you can lock that down. And the cool thing about that is it's actually more secure than RDP, right? So I'm going to go off on a slight tangent here. RDP is insecure by nature because I can't guarantee what you did. I don't have an audit trail for the actions you took. There's no way for me, short of installing like a keylogger and an XY button map to find out what files you open, do all that logging. There's no way for me to tell what you did when you logged in and performed actions. With Gia, two things are true. One, I can transcript every single command you wrote, right? Everything that you put into the prompt. Two, if you start running commands that you're not authorized to run, that generates security alerts. And they will fail. You'll get an error that fails out and won't be able to complete the action. The other interesting thing about Gia versus an RDP is when you log in with RDP, your credentials can end up in LSAS, right? And I can use Mimikatz, grab your credentials out, pass the hash, I win, right? Gia doesn't do that. Gia creates a virtual admin account, as I understand it on the box, that is generated at login. Those credentials aren't stored, but even if I did manage to grab those credentials, they're a virtual admin account tied to that specific box, to that specific configuration. You can't go anywhere or do anything that that thing couldn't do anyway. So you've created a safer environment where you've reduced risk substantially. So I think part of the problem is that we don't approach security with those kinds of conversations. We tend to just go out there and be like, well, I can't script, well, you're stupid. They don't respond well to that, right? Nobody does. So the truth is that we need to sit down with security, we need to bridge that gap, have the conversation where we say, okay, I understand that you're leery of scripts, we are too. So what we decided to do is put our scripts in source control, put them in the private gallery. They're vetted before they go. People can run the scripts from the gallery, those will be signed and approved, etc. Those things can be deployed out to your servers and your workstations, whatever, and run and executed. But they're in a safer, controlled environment. We've got unit tests for them. You can make a huge case out for security for why it's safer and better, and slowly change their minds towards a better way to do things. So I'm going to end there. Does that make sense? Does that answer your question? Okay.
And also PowerShell works more than server.
Yes.
So,
Yep.
and the example that I was thinking back on you have a group of developers.
Can you speak up a little bit for the...
Sure.
Yeah.
There's a group of developers.
Yep.
And in most companies, and developers, well, I need this tool, I need that tool, I need that tool. Oh, PowerShell will do that automatically. How long before somebody figures out, I can inject stuff into the machine, so you have an internal repository that you can take care of it.
Yeah, that's a good point. I mean, you would, so it comes down then, it's a conversation, what is better? Is it better to build an organizational centralized point where we're going to be doing these things, or to allow teams to splinter off and do their own thing, and then you don't have a source of truth? And so one of the biggest things we've noticed in the PowerShell community at large, right? So writing modules like Saki and PS deploy and Pester, right? Previously, everybody was doing their own specific build stuff, right? And it's going to be the same thing for every end user, for every team across the organization. Everyone's going to solve a problem, but if that problem is cross-domain or cross-team, they may not talk about it. They may never think to share it, and then everybody duplicates that effort, right? So if you end up with 7 sources of truth, and they're all kind of duplicating it, some of them are better in some places than others, that's not a net benefit, right? Any questions from this table? Brad, you're uncharacteristically quiet. No? No questions?
Thank you, Nick.
Good.
So I want to clarify, so Gia is specifically meant to be a remote management tool. It's still on the remote endpoint has an admin or some account that runs the commands. You're just specifically restricted to the remote machine.
Yeah, so it's you did so with the caveat that what I know about Gia is what I have learned from other places, and I'm by no means like your greatest me on the planet, right? Talk to Michael Green first, because he knows a lot about this and he's pretty passionate about it. You can find him on Twitter at migreen with an E, MIGREENE. Super smart guy, talks a lot about Gia, good evangelist for it. Anyway, so specifically towards Gia, what it is a DSC configuration where you say when somebody logs in, right, if they have access to this Gia endpoint, because you can specify who can access the endpoint. either by AD group or by username or whatever. So if they can access this endpoint, here's what they can do, and here are the settings for that, right? But if I were to log in with RDP and open up PowerShell as an admin, I can still do everything that's already on the box. One of the things that they're advising for people moving towards GIA is to start with what we think of as the in case of emergency break glass endpoint, right? So you can do anything, but because we're going to log all of it, now when you log in and you do those actions, we can find out what normal work looks like, right? And then we can create restricted endpoints based off that information. Because otherwise, I don't see a good way to get there. Does that make sense?
I think the first step is you're never actually logging on to that box. It's all remote management.
Right.
You're not logging into the box, you're remoting the box to PowerShell.
Correct. Yes. So what instead of what you would normally do, where you would make a Kerberos authentication or whatever as you to that box, correct? You're basically, it checks to see if you can hit the GIA endpoint, and then you're remotely administering that piece. Is that what you're getting at? Okay. Yes, that's true. To my understanding. Clarify that. So is anybody, so since we've kind of finished the presentation, if there's no further questions on that, we could take a quick break, and then we can have sort of a discussion about anything that you want to stay for. If you'd like to head out, feel free to do so. Otherwise, we're going to sit and talk some more PowerShell, kind of see what people have done over the last month. Have some discussions over what you're doing, what you're having a hard time figuring out, what you're interested in learning. Just kind of have some conversation at this point. So is there anybody to go to the bathroom? Good. Let me go ahead and turn off the stream. Andy, you look like you have words. No? No words? So I'm going to close the live stream up a little bit early here.